Hey everyone, so I'm here today with Jehan from the Informal Cosmos Hub team. I think Jehan, it's fair to say, I mean, you're a very humble person, but still say that you're the man of the month, right? We just shipped the replicated security on the Cosmos Hub, and so you were a big part of that. I think you've been working on that since 2021. We talked about it, by the way, on the Ethan Cosmos Hub video. I had a quick, actually not a quick, 15 minutes interview of Ethan about the history of the Cosmos Hub, and we talked about the way you kind of took on Interchain Security and built a team around it. I know now there's a lot more people working on it, and it was an idea that was there previously, but you're kind of the guy who made this happen. So I'm happy to have you today. I think it's very good timing, and we want to talk a little bit about the launch. But today is a video about the future of Interchain Security, and we're going to talk about everything that is coming up, at least on that specific endeavor for us. So first, Neutron just launched. I think it took 2 days. Maybe you can describe why it took 2 days. It was supposed to be a little faster.
Yeah, and it will hopefully be faster in the future as well. But basically, what happened was there was unfortunately an oversight in some of the code that we had written for Interchain Security, which meant that ledger devices and multi-sigs couldn't sign certain transactions. And these transactions were called a signed consumer key, and that basically lets validators use a different key on Neutron than on the hub. And validators want to use different keys on different chains for operational security reasons. There's no strictly speaking software reason that has to be like that, but it's just like if they can avoid moving keys around between computers, that's just going to make their setup more secure. And so for that reason, that's important for them. And so what happened was we started hearing about it like maybe a week or a week and a half before the launch that people were having problems sending these transactions, which was surprising. But I guess everybody waited till the last minute. So when we heard about it, we quickly pushed out a fix. We got an emergency upgrade out this Monday, which Monday morning, beginning of this week, which fixed it. The problem was that what's called the spawn time, which is kind of when the consumer chain's Genesis file and the hub's half of the IBC connection is sort of locked in place, had already passed. And so validators were not able to assign their consumer keys anymore after that point. And so we had to reach out to a lot of them. And we did this with help from a lot of other teams as well. It was a community effort to sort of get the word out, get everyone on the same page, that if you can, please bend the rules and run with your hub key on the consumer chain on Neutron. And so a lot of validators did it, and they helped us out with that. And we were able to get enough power together to start running the chain. And then on Wednesday, it did start producing blocks at the very end of the day. And we still don't have, I think, all the validators on. So things are running a little bit more slowly than they usually would, which is actually kind of an interesting situation. Or I guess if you're interested in how consensus protocols work, but yeah, things are running, and yeah, Neutron's up.
Well, everyone has to be interested in how consensus protocol work now. I think there's no choice when you work in the Cosmos ecosystem, and there's a new chain, almost every day, at the very least every week. I think it was also interesting to see that some validators did not want to perform this, to use the same key, and actually flat out said, yeah, no, we're not going to do it. So it's kind of interesting that there were like different reaction, and as a team, working on that stuff, I think we should kind of expect the worst in these situations. So replicated security is a complete. I think we did an episode together on a while back about replicated security, and how that worked, and the fact that the Cosmos Hub and the consumer chain were sharing the validator sets completely. There was a complete overlap between the two set of validators. Today we want to talk about the future of Interchain security and what comes after replicated security. Maybe first, what is going to come with replicated security. So there are cool things that you can do when you do share the same validator sets. There are a couple of problems with it, or rather drawbacks, but there are a couple of pros and things that actually are helping us with that setup. So one of them is called we kind of named that Synchronous IBC. So can you define what is Synchronous IBC, and why is the fact that the consumer chain share the same validator set as a hub a benefit for that?
Yeah, I gotta be clear though. Synchronous IBC, it's interesting, but it is just an idea now, and so not in development. It's still in the idea phase. We've been kicking around ideas with yeah, it was part of, actually we talked about it as part of Adam 2.0 with Sam Hart and stuff last year, but also Nick from the Duality team has a lot of interesting. He's thought about a lot actually. But the idea there is that with well, I guess okay. So I guess I'll start at a low level here. With replicated security, you essentially have a bunch of chains running in parallel. It's sort of like multi-threading on a CPU. And when you run things in parallel, you have more scalability because you can have different computers with different cores on a chip working on things at the same time. So the benefit that so for instance, you could launch Neutron. Now, I don't know if this would be a good idea for other reasons, but like in theory, you could take Neutron and actually put it like in to the Cosmos hub. Basically, like you would just take their module and just like paste it in to the Cosmos hub, like code base, and then it would run as one chain. And you could take every consumer chain, paste them in, and they'd all run as one chain. The problem you'd have there, first of all, there'd be massive problems from a workflow and software development perspective, but from purely a theoretical perspective, the problem you'd have is that all of those transactions would all have to go in the same blocks. They'd all have to come one after another in the same blocks. And so the size of a block is really limited by many things, but among them, CPU speed, to get through all the transactions one after another. By having consumer chains running in parallel, they all share the same security, but their transactions are all able to run at the same time. And so that's great, but there is a little bit of a cost. And that's also kind of the Cosmos thesis as well, even beyond interchain security, is the fact that you have parallel chains running. That's kind of the whole, and connected with a really good connection layer, which is IBC. So it allows a really good scalability and also independence of workflows and stuff like that. But it does have some drawbacks, which one of them is that it's a lot of, I guess I would say a lot of work to deal with, to think about and deal with asynchronous things in general in software. So when you have one step that's going to happen, and then it's going to be sent to another thing, and then there's going to be a step that's going to happen there, and things could have happened in between, and all this kind of stuff. It's like you sort of have to deal with the fact that it's a much more complicated situation with time involved and stuff like that. That's when things are asynchronous. That's the kind of communication over IBC is, because chains are running on their own time, own schedule, and different things could happen on different chains between the time the different parts of your transaction take place. And so one example is for flash loans from Ethereum. Flash loans are not possible with IBC right now, because a flash loan is basically on Ethereum or other smart contract platforms. It's where you say, I'm going to borrow this money, I'm going to use it to make some money elsewhere, and I'm going to pay back the money like all in one step. And so what's cool about that is you can borrow basically unlimited amount of money, because if you're not able to make it back, the whole thing gets canceled, and it's like you never borrowed it at all. And so that's used for things like I don't know what it's used for. It's
used for
hacking
protocol in general.
Well, there's hacking, but I'm sure there's good things people use it for too. But there's financial things like arbitrage and stuff, where people are moving things between exchanges to kind of even out the prices and then make a buck on the side. And so it's useful for those kind of things. But that's not possible with IBC right now, because you borrow it. Let's say you were to borrow it and you're going to move to another chain to make money on the other chain. But like by that point, you can't roll back the fact you borrowed it anymore, because it's not all part of one thing anymore. It's part of a series of steps. And that's one example. Flash loans could be great to have that, but there's also, it touches everything basically once you get into dealing with the programming. It's just always a lot easier to deal with synchronous things. And so one of the things that'd be cool with replicated security is, since you have all of the validators are the same validators on all the chains, you could potentially make it so that people could choose to say, when I want this, I'm going to borrow money on this chain, and then I want it in one step to be transferred to the other chain, and then like transferred back and return the money, pay off the loan. And I want to make it so those things all happen at the same time. That is, nothing happens on any of the consumer chains between the separate parts of my transaction. And that's the idea with synchronous IBC. And it will require a lot of work. We haven't even figured out how we would make that work. It will require changes to probably to Tendermint or Comet. in IBC and stuff. But maybe there's, I don't know, maybe there's easier ways to make it happen. But that's the kind of thing that replicated security enables. And that's cool because what it lets you do is it lets you, for most transactions, have the scalability and the low cost and speed that people associate with Cosmos. But then when you have somebody who for some reason wants to do something with this extra power, with the synchronicity, they can pay a little bit more to do that. So you get the best of both worlds.
Yeah, I think by the way, it's not going to be completely synchronous IBC. It's going to be close to synchronicity, and it's probably what you mentioned here is atomicity, like either everything
that's right,
or just one part executes. I guess
that's right.
Call it, I guess we should call it atomic IBC rather than the synchronous IBC. Since
atomic IBC, that makes sense. That also sounds like atom, which is cool.
Yeah, and for
that's what you want. It's true. It's atomic. That means atomic means it cannot be split. From the Greek word. It's basically that if one thing fails in this sequence of transactions, they all fail, and that's what enables those use cases like flash loans.
Yeah, and I was joking about flash loan being like a great tool for hackers because that's kind of what has been happening to Aave and Compound and all these platforms on Ethereum where you actually have atomicity. But obviously, it's there are also good use cases like arbitrage is a big one to make sure that the prices are the same across the entire atom economic zone. That's actually a very good thing, and that one reason why a chain like Neutron would want to be in the atom economic zone is because the DeFi apps on Neutron would be able to see and have the same level of interoperability with Stride and the others than you would have on Ethereum, or at least much closer to it. So that's why it's a good thing and not a bad thing. So another one that would be like another use case for replicated security that is interesting is multi-hop IBC. So maybe you can define what is multi-hop IBC and why it's interesting, and how the hub would facilitate that as part of the atom economic zone.
So when you have two chains that are connected by IBC, the way it's done right now is they have a direct connection with one another, and you have to run a relayer for that. Someone has to run a relayer for that connection. So if you have 100 different chains, if they're all going to be connected, you need to have, connected to one another, you need to have like, I guess 100 times 100 relayers connecting them all. So it becomes a lot of work. What multi-hop lets you do is you transfer the packet first to one chain, like a hub, if you will, and then from there it gets transferred to the destination chain. And so what this does is it allows for less infrastructure to have to be run. So you could, for instance, have, if we're using, let's say this is a service that the hub offered to consumer chains, you could basically have one connection between Osmosis and the hub, and then from there it would be relayed on to whichever consumer chain it was destined to. So that's the kind of stuff where you can start to have synergies within the atom economic zone.
That's right. That's actually why the Cosmos Hub is named the Cosmos Hub, is because this vision of the routing hub is kind of the basis for the name, because it was part of the original white paper. Something that we discussed, like to build on top of that, was the ability for the hub to kind of clear denoms. So briefly, and we're going to move on to opt-in security afterwards. Can you explain the problem with denoms in Cosmos and why it causes troubles for fungibility of tokens?
Yeah. So let's say you have some Stride token, and then you transfer it to Neutron and you use it on a smart contract in Neutron. Now, when you transfer that, you do whatever you did on Neutron. Maybe it's sent to someone else. Maybe I sent to you on Neutron. You take that token. Now it came from Stride, and now let's say you wanted to transfer it to Duality, let's say, and so right now, what will happen is that token, it's not considered to be like Stride. It's not considered to be Stride token because it's gone through Neutron. So it's like Stride token wrapped by Neutron. And that's different. It's a different coin, actually. On Duality, it's going to be a different coin with the way things are currently set up than Stride token that came straight from Stride. And so in the multi-chain world, outside of the atom economic zone, outside of replicated security, it has to be that way because you have different security on the different chains. So if you have this the Stride token wrapped by Neutron, you're depending on both the security of Neutron and the security of Stride as well. And so whereas the Stride token transferred directly, you're depending only on the security of Stride. So it's like, that's why there is actually no way to sort of consolidate them simply. There is some really interesting stuff from Strangelove, the packet forward middleware. That's where I would actually send it back through the originating chain, like kind of do a loop to sort of unwind everything. But there's another possibility as well with replicated security, which is that you don't actually have to consider them separate anymore, because Neutron and Stride, at that point, they all have the same security. It's the hub security. So what you can do then is on duality, you can actually consider the Stride wrapped by Neutron to be the same token as Stride direct. So that's another way that you get the synergy from sharing a validator set.
Yeah. So that's at least two things that we can do with replicated security. On the technical level, on more of the financial and building like a tight partnership kind of deal, there are a lot of other ideas. I will talk to the team at TimeWave that is building kind of a very similar thing than the in-chain allocator that was part of the 2.0 white paper, Atom 2.0 white paper last year. You have stuff like you could have the hub lend some tokens to a consumer chain, and that consumer chain wouldn't have to put up collateral for that, because in the worst case scenario, the hub could just claw back all the funds because it has control over the chain. So that's kind of that kind of concepts. I think we'll go over that with the guys from the TimeWave team. But moving on to what's coming next for in-chain security. There's one thing that everyone knows that it's coming, and actually pretty impatient, especially some validators, is opt-in security. So can you explain what is opt-in security and why are the validators so impatient to have that ready?
Yeah, so opt-in security, it was originally called Interchain Security V2, and then for a while we were like, okay, let's just buckle down, focus on V1. But it does appear that that's probably a good next step for us. And opt-in security, pretty simple. It's just like replicated security, but validators can decide whether or not they want to validate on a particular consumer chain. And this is really nice for a lot of reasons. But I will mention that using opt-in security, you're foregoing the benefits of the Atom economic zone. So all the stuff we talked about, the synchronous IBC, the denom stuff, that was all, that applies when you have one validator set that's the same. For opt-in security, you'll have validators who are validators on the hub. They might not even be in the hub's active set. They might not even have enough Atom stake to actually be in the active set of the hub, but they can still validate on consumer chains, which is cool for them. And they choose whether to validate on a consumer chain. So that means that in principle, you don't need a governance proposal for the consumer chain to launch. It doesn't need to be looked at as carefully. You're not going to have people debating about whether or not the chain is good enough, which I think is awesome for the Atom economic zone to have that quality filter. But with opt-in security, you'll be able to have chains basically just be able to put out a transaction saying, hey, we're launching, and if you want to validate, here's where you go. And so then individual validators can use their stake to validate that consumer chain. And so that could be a really good way for consumer chains to still get a lot of security from the hub, but not have to have that barrier that they've got to get everyone to agree. So it's a little bit of like a launch platform. And so, that's the essence of opt-in security. Any questions? I can also go into some of the things that we need to do to make it happen too. But yeah,
we're going to talk about that. I think the reason why replicated security is a tough one for a lot of validators is because they can't, they have to validate. So whether or not they believe that chain has a future, they will have to if they are part of the Cosmos Hub active sets. And so that's a problem because they want to be able to make these calls. The same way, like right now, there's a lot of validators validating on many sovereign chains. They always have the option to do it or not to do it. What opt-in security is bringing to them is this freedom of choice. So this is why a lot of validators are eagerly waiting for that. But so can you explain? So now let's explain why it's not there yet. Why it's a different thing than replicated security. What are the technical problems? Especially, I think you're going to mention proof of stake problems more than technical problems of why this is not something that is as simple as it seems.
Yeah, that's right. So that's kind of also why we decided to focus on replicated security last year was with some of these unanswered questions. And so what it comes down to is, well, I guess in terms of programming, there's a little more extra work but honestly, it's, it's much the same as replicated security from a programming perspective. Some work to make it happen, but not a big deal. But yeah, the real issue is on the proof of stake level. So the set of validators that opts into a given consumer chain, it is not the same as the Hub's validator set. It's a different validator set. Even though they all are in the Hub's validator set, they are not the Hub's validator set. For instance, you could have, if you let's say there's 10% of the validators on the Hub are just bad and evil people. And so, and this is what you got to consider when you're, thinking about this proof of stake stuff, is you're trying to avoid, you're trying to make it work with a dishonest minority, basically. And so on a consumer chain, given opt-in's consumer chain, it could actually be that every validator that's opted in to this consumer chain is one of those evil validators. And that's sort of the root of the problem. It's called the subset problem. It's that you may be able to say the Hub's validator set as a whole is an honest majority, but you can't say that about any given subset of the Hub. And so for that reason, you couldn't necessarily say, I guess I won't get into all of the deep game theoretical stuff here. But what it comes down to is if you have validators who have $100 million in atoms staked to them, validating a certain consumer chain, you can't necessarily say it's secured by $100 million in atoms. That's kind of what it comes down to. And so the way you can solve that is with fraud proofs. So basically fraud proofs, or something like fraud proofs, which we can talk about in a second here. But fraud proofs are are kind of a computational method of basically presenting proof that a validator did something bad. So basically, what we're worried about is a validator. Now they will be slashed with a double sign. That's important. But they also could just change the state that they would just take all the money out of your wallet or something, or just steal all the money on the chain for themselves. And they wouldn't be double signing anything. They'd just be actually just approving a completely incorrect block. And so right now, there's no way to stop that. With fraud proofs, it allows somebody to present proof that this happened. And then those validators could be slashed on the Hub. And so once you have that, then opt-in security is safe to use. And the thing with fraud proofs, though, is that they're always, I should probably check in on all the projects. I know they're working on that at Celestia, a lot of different projects in the Ethereum space, also doing a huge amount of research into it. But it always seems like, they're perpetually 6 months out from having, they're almost ready, So maybe this time they really are almost ready. But if it happens that we're ready with the other aspects of opt-in security before fraud proofs are ready, there does exist the possibility of actually just using a governance proposal on the Hub, where you just say, let's vote on this, on whether the subset of the validators using opt-in security did something bad. And that could be enough to keep them honest. And what that would do is that if you're opted into a consumer chain, then you are eligible at that point to be slashed by a governance proposal about where someone's alleging that something went wrong on that consumer chain. And it would then be up to the voters and the governance to sort of sync up their full nodes and do whatever is needed to verify that proof. And it wouldn't be done in a completely automatic computational method of real fraud proofs. It'd be more expensive kind of to deal with. But to me, it seems likely that it would be a workable system to at least get us started before fraud proofs are all the way there. But that is also something that I think that the community needs to decide on, whether that's a direction that should be taken. So that's probably something that I'll be writing about more in the future.
So Jehan, initially on the Medium that I think Billy published in 2021, there was something that was mentioned called ICSB3 or layered ICS. Can you explain what was the idea with that, and whether that's still on the agenda for us?
Yeah, so layered security was the idea that you would have multiple provider chains providing security. and even that you would have two chains that were able to sort of provide security to each other. It may sound familiar if you know about mesh security, but layered security was first. I guess, I'm not sure whose idea it was, but Billy wrote about it, and that was about 2 years ago now, probably. And so our priority has been replicated security, opt-in security as well, a little bit, and then layered security. That was like the next level. We hadn't really started working on it yet. Layered security would basically require you, if you think about the way that opt-in and replicated security work, is that you are using the validator set of the hub or of the provider chain. And now if you're using the validator sets of two provider chains, what does that mean? Does that mean that the consumer chain has a validator set that's twice as big? So instead of 175, you now have, what is that, 300? That's 350. Yeah, you now have 350 validators. That's still possible. That can work. However, it starts to get more and more. Tendermint has a limit to how many validators you can have. Stuff starts to slow down, becomes too many. And or what you could do is you could say, well, we're going to take, the top, whatever it is, the top 75 validators from this chain, the top 75 validators from this other chain, and we're now going to have 150 validators in the consumer chain. Then what if you have a third provider chain? What happens then? Maybe if you keep throwing away, only taking the top, you might have 5 or 6 or 7 different provider chains happening here in the system. And if they all have the same validators in the top, then you might end up with a situation where it's like the same it starts to become, and there's probably ways of you could deduplicate them and stuff like that. And, but it starts to become kind of unwieldy and confusing. And it, could be thought through in greater detail. I'm sure we come up with solutions, but what ended up happening was that last year, around the time of Cosmoverse, it turns out that Sunny came out with his idea for mesh security. And so mesh security actually has it's a lot like layered security, but it has a really elegant way of dealing with this problem of what you do with all these validators, the validator set, and how do you consolidate these validator sets. And the way it deals with it is it doesn't take the validator set from the provider chains at all. The consumer chains, or I guess in mesh security, is not necessarily provider consumer. So, but a chain using mesh security, you can still analyze it through that lens though, which makes it actually easier to understand. But let's say the consumer chain, which may also be a provider, but we'll ignore that now. It has its own validator set. These validator sets are just on that chain. And what the security is that comes from the other chains is actually just the delegators. So mesh security, if you're a delegator on one chain, you can say, hey, I also want to stake my coins on this other chain too. And so what that does is you sidestep the problem completely of how do you combine these validator sets by not combining the validator sets at all. Given that there is a lot of momentum behind mesh security, and it sort of does simplify things a lot, we're sort of more putting our weight behind mesh security right now, and we want it to be an option that the hub will support. And it's actually something where the hub will be really strong in mesh security. And so because the hub is going to be, if you want security for your chain and you're going around and connecting to these different chains to get security, I mean, connecting to the hub right now, that's going to get you a huge amount of security. And you also that's because the hub has a relatively large value and a large stake compared to other Cosmos chains right now. But it's also because we are getting a head start on shared security, and we have already a delegator set who are kind of used to, or once mesh security is out, we'll already have this delegator set who's got this head start on being used to that this is what Atom is for sharing security. So I think that the hub is really strong in the mesh security world, and so that's why we're behind it all the way.
Yeah, so I think one benefit of ICSB3 or layered security is that you would be able to enlist validators from the hub. You kind of tested validators, like these guys have been there since 2019, and you would have an easy way to kind of build upon that. With mesh security, the issue I was seeing at the beginning is that you wouldn't have that validator set. You would have no way to enlist these validators, which I kind of consider a drawback. But then in recent days or weeks, I actually talked to Sunny in Austin about that, there's now this new idea of the hub being kind of a launch platform for mesh security. That would be something, Jehan, that would be great if you can explain our listeners.
Yeah, so one of the things with opt-in security, where at first it will have an edge over mesh security, is that depending on how you do it, I guess. But over just mesh security by itself, opt-in security will have this edge that you can just put in a transaction and say, hey, we're starting a chain. Here's how you start validating. And you have validators opt in and they bring their entire stake with them, and you could build up a pretty good level of security on your chain very quickly using opt-in security because you're using that stake from the hub. So what would be possible is to sort of have a launch phase for a chain where it's basically opt-in security during the launch phase, and then it offboards very quickly to mesh security. And so what would happen is that you'd have this phase where the people starting the chain would put in this transaction saying, hey, we're starting a chain. And then you would have hub validators with their delegators opt in to validate on that chain. And then you would do like a seamless transition over to, similar to how we're doing this transition with Stride. We're about to do it with Stride. It's like a similar sort of process where you would do a transition from one type of security to another, and it would transition from opt-in security to mesh security. But when it became a mesh secured chain, it would start out on a really strong footing, because it would have all these hub validators already validating it in its validator set, and they would have all of the stake from their delegators already signed up. And from there, they could go out from a very strong position of strength, go out and connect to other chains, and then continue to connect to the mesh and add to it. But I think that's an exciting way that we could sort of take the momentum from replicated security, keep the momentum through opt-in security and into mesh security. But I also think that replicated security, like with the Atom Economic Zone, I think we'll always see it being this kind of distinct use case. And I also think opt-in security, we'll have to see how things evolve in the future, but I think also opt-in security people may also continue to use opt-in security and replicated security and mesh security for different use cases.
Yeah, I completely agree with that. I think replicated security in particular, the forming of this Atom Economic Zone with the benefits outside of just security are not going to be transferable very well to mesh security. And so the chains that are the most, that is the most important for them to get this kind of liquidity, to get this kind of network effects from the Cosmos Hub, they're going to keep using replicated security. The others that are after, more like the economic side, they will go for mesh, is kind of my expectation for this, which is perfect because at the end of the day, the Cosmos Hub, the Cosmos Hub validators cannot run 1,000 chains. We have to focus on, 10, 20 high quality chains that bring a lot and form like a coherent zone for the Atom community. So moving on to one last I guess competitor.
Wait, one more thing actually that could be cool is you could also transition in I don't know if it's the other direction really, but you could transition from opt-in security to replicated security. That might also be a way things go in the future. So you're going to have this exclusive Atom Economic Zone of these chains that are pretty curated and are pretty tightly connected, and you might have a chain that wants to get in there, but they don't necessarily want to go with the governance proposal right away. What would be possible, I think, is to have an opt-in security chain and basically let them build up, let them get a lot of the validators opted in. And maybe once you have enough validators opted into the opt-in security chain, you could have an automatic process to get promoted to a full replicated security chain. Of course, that would have to be thought through. You probably want a pretty high number of validators to make that happen, like, I don't know, 90% or whatever, if it was going to be automatic. But I think that there's also some interesting stuff there.
Yes, very interesting stuff going on there. Another competitor to the hub, people may think I don't think that's the case at all, but there's been a very popular project in the Ethereum space that is called Eigenlayer. And so Eigenlayer is also a project that works into this shared security space. Can you explain what Eigenlayer is doing very briefly, and how that could be like good inspiration for the Cosmos Hub to kind of use the same concept of it's very similar to opt-in security. I will let you explain what Eigenlayer is doing and how they may work for the Cosmos Hub.
Yeah, so Eigenlayer is a lot like just Interchain Security in general, and it is it's basically they took sort of the architecture of Interchain Security, or I don't know if they're working independently and stuff, but it's very similar. But the thing is that every part of it is like swappable. It's sort of with smart contracts on Ethereum, it's a little bit easier to do things that way, and with smart contracts in general, I think you could do it with Cosmosm too, but. You take every part of Interchain Security and you say you can plug in your own contract to do this. And so people building projects can modify how things work a lot more. And so in theory, it would take a lot of work, mind you. It's not happening overnight. It would take a lot of work to make everything work. But you could implement replicated security of sorts on Eigenlayer, and also opt-in security, even mesh security. Making it work probably, like I said, would be a lot of work, and I don't think it's going to happen anytime soon. But what we could also do is from that, take the inspiration to sort of break things up a little bit more and make things a little bit more customizable. And it would be possible to do something that you could call generalized ICS. So where you would say, instead of saying, either it's mesh security where delegators opt in, or it's opt-in security where validators opt in, or it's replicated security where everybody opts in at once, we let the project supply a contract that's going to do one of those things. And then the same with distribution. That's another contract that can be supplied by the developer with Eigenlayer. So we could also do something similar. Instead of saying that we use this distribution system to to distribute it to everybody, or only these validators or whatever, you could say, we let the developer program their own distribution system. And so that is something that might be interesting to do for more flexibility, maybe as sort of, in the future, kind of once we've gotten a lot of these ideas fleshed out, to sort of unify everything and kind of make it all more unified and maintainable.
Yeah. So I think what people can get from that is there's a high likelihood that ICS v3 layered security is kind of out of the window, at least for now, until we find a proper reason to do it. There's a new ICS v3. It's called generalized ICS. It's kind of way more exciting, and it's also very well. It integrates very well with mesh security than what we've been building so far. Obviously, none of that is set in stone, and there's still a lot of specification work to do at Informal to make sure that works. Maybe other people would want to contribute, by the way. In that case, it may speed up the development process. But yeah, I think that gives us a great idea about what's coming up in terms of Interchain security. There are other things that should and could be built for the Cosmos Hub. This video is going to be focused strictly on the idea of shared security. We can do another one with the other stuff we've been discussing at Informal and also outside Informal. So yeah, Jehan, any last word, any last comment, observation that you want to make before we wrap this up?
Yeah, I don't know. I can't think of anything. I guess I want to I suppose thank the validator set for participating in the Neutron launch, and also thank the Neutron team for being the guinea pigs, and yeah, and then also everyone who helped us reach validators, helped us fix things. Yeah.
I want to shout out Boo Boo Nodes, a couple of French guys that have a hobbyist validator, and one of these guys run back to his home, back to his computer to make sure that we would go from 66% on Neutron into 67%. That was kind of cool and kind of funny at the same time. So shout out to Boo Boo Node. Don't validate to Boo Boo Node. They are 100% commission validator, but still, shout out to these guys. Cool, Jehan. Well, thanks for coming today, and let's do another one maybe in a couple of months.
Okay. Bye-bye.